Hi, I'm Old Sneelock. Welcome to another episode of Old Sneelock's Workshop. Time to make some linkages for the grinder treadles. The treadles are working, and the grinder crank actually works, but I need to make a way to mechanically link them. Now, I still need to make the axle for the wheel, but before I take everything apart, I thought it'd be a good time to cut the linkages to length and set up the bearings. The original linkage was a ball bearing. Now this ball bearing has seen better days. It's all worn out and the balls fell out of it. The ball bearing was mounted in such a position that as the wheel turned, the linkage was able to pull on that bearing and provide motive power to the crank. It also reduced the drag between the crank arm and the treadle. So I want to repeat that concept with a bearing on this crank. A while back I bought a set of bearings for a skateboard. This particular brand came 8 bearings to a pack. And since they're inexpensive little bearings but very high quality, I thought they would make good bearings for projects. Now the hole in the crank is just the right diameter to put a 3/8 bolt into. I can run a tap in there and that bolt will thread right in. But the shaft on this bearing is about 5/16. I'm going to have to make a step shaft. That'll let this 3/8 thread fasten into the crank, and then I can reduce the diameter of the shank out here to about 5/16 and then put a thread on that so that I can lock this bearing in place. That'll let me have a nice even line up on the bearing so that I can hold it in place, and it'll let it rotate around that crank without any problem. A little bit of doing, but nothing impossible. It's always easier to erase a line than it is to cut a piece of steel again. So similar to what I did when I made the bearing blocks for the main bearings, I'm going to draw up a sketch of how I want to mount this bearing onto the shaft. Kind of taking an idea from this, by keeping the steel ring around the bearing as thin as possible, I can keep the weight down. There's not going to be a lot of stress on it. The OD on the bearing is 7/8. I want to give myself enough thickness in that ring so it can support it well, but I don't want to have it real heavy. So I'm going to take the outer ring out to 1.25 inches. That'll give me 3/16 on the side. Now for the linkage itself, since it's only under tension, I'm going to use this 3/16 by 36-inch rod. Measuring up from the treadle to the center line of the shaft, I've got 25.5 inches. .25.5 inches from the center line of the crank to the top of the treadle. To attach the 3/16 rod to the bearing block, I'm going to leave it a little tab about a 1/2 inch long and a 1/2 inch wide on the bottom of the bearing block. That way I can drill and tap it for a 1024 thread and thread the end of the rod, put it up in there with a lock nut, and it should hold just fine. So to make this bearing block, I'm going to need to start out with a piece 1 3/4 inch by about 1 5/16 inches. That'll give me enough room to make some adjustments along the way if I need to. Said I needed 2 pieces, 1 3/4 by 1 5/16. Since this little tab right here is 2.5 by 3, I have more than enough steel to make it out of just that corner. So I'm going to try and leave as much of this steel on there because you never know when you might need a full-size piece. Now we just got to wait for the dicom to dry. This is something that I don't use very often, but I probably should. I keep forgetting that I have it. It's a height gauge. With one of these and the appropriate tooling, I can make very precise settings. And I can scribe the marks exactly where I want them. Now this is a vernier type. Not something that you'd find in most shops today. They're all digital, if they even have a height gauge. Quite often, companies have switched and gone to CMMs. Now what I would really like to have for this is a cast iron knee. Because then I would clamp this plate to the knee and it would hold it vertical.
Not having such a precision piece of equipment won't stop me. I'm just going to make do with this piece of railroad iron. You don't always have exactly what you want. So sometimes you just have to make do.
With the scribe set up on the top of the bar, just like that, the vernier lines up exactly with the 0. That means that this bar is 1 inch off the bottom.
Once I have the setup done, then it's just a matter of marking the lines where I want them. Takes a few minutes, but it's a lot easier than trying to do it with a straight edge and a ruler.
Now this little height stand is awfully light, so I can't really scribe very hard, but it did give me a good line to work from. So I can take this nice sharp carbide scriber, go through, and scribe the line. I set the carbide into the line, bring the square over to it, I'm able to make nice clear lines.
Going back to the sketch, I can see that I've got an 1 3/4 inch long block that has to be 1 5/16 wide. I've got the lines laid out on the steel plate. I added in some reference circles so that I'll know exactly where the holes go. And then I'll be able to cut these blocks of steel.
Now that bearing set in there, I should have 2 good little linkages. Now it's time to go out in the garage and use the grinder and cut these plates out. And I got to come down and bore them. I'm going to do that before I round off the outside edges, just so I'll have something nice and square to hang on to in the forejaw. And in case some of you are wondering what I'm using for a surface plate, I'm using my high precision stone tile. Actually, it's a piece of stone tile that my mother had for cutting glass on for her stained glass class. It's got leather on one side and stone on the other. Is it high precision? No. What I'm doing is not high precision either. If you have any suggestions for a new video, questions about today's video, or any of the other videos on the channel, just drop a note in the comments. You know I read them all. Thanks for watching.